We have this lesson we'll go through in just a couple of minutes. We got done with the quiz. We'll start a new quiz tomorrow. We have, I am very confident, much more confident this year in the Regents Review that we're going to do than last year. I've started to prepare all those materials. And we have such a better sense of direction now than in the past. Things are making more sense to me. And if they make more sense to me, I'm better able to help you. So we should be ready as far as all of that goes. All right. I went through, God, some practice Regents exams. I went through some other things, and so many questions on box and whisker plot. So many questions on exponential functions, on linear, arithmetic, geometric, quadratic, vertex form. All of the stuff we've been doing for the last, I'd say, 6 weeks or 8 weeks is just all over that Regents exam. So keep slugging away, keep working away, don't slow down, keep firing and working as hard as you can. And before you know it, it's pretty much over. I ran a thing today. It looks like 32 teaching days and 42 total school days left before the end of the year. So, man, that goes quick, right? Before you know it, the school year will be over, and so many people are involved in stuff right now. You got kids playing sports, you got NISMA, you got concerts at the end of the year. You got like all of these things going on, and your time just gets absolutely clobbered. So you just got to kind of stick your nose to the grindstone and keep working out. Front row, if you guys could scooch back, in fact, each row a little bit closer. All right, so we're going to start with a stem and leaf plot. It is, as far as I can tell, it's not part of the new curriculum. It was part of the old curriculum. I just don't want to not go over this and then wind up having it on the test. So I'm going to cover it quickly. Every number here is between 0 and 49. So my stems will be 0, 1, 2, 3, and 4. And then, let's see, we got 38, 15, 32, 20, 28, 44, 5, 40, 38, 22, 20, 35, 20, 30. Okay, am I done?
No.
No, what do I have to make sure I do? Put them in order. Good. 0, 1, 2, 3, 4, 5, 5, 0, 0, 0, 2, 8, 0, 2, 5, 8, 8, 0, 4. Okay, now am I done?
No.
What do I got to do now? Yeah, I got to put a little key down there, so I could go 3 - 0 equals 30. This is so important because years ago, this type of material, when we gave a Regents exam 20 years ago, they were really pretty hard. Then they changed them to really easy. The content was the same, but one of the big differences they had is that when I was in high school, when I took a Regents exam, you had to do every Part 1 question. Then you got to choose 4 out of 7 Part 2 questions. And each Part 2 question was worth 10 points. So let's just say they put a stem and leaf plot on the test. If you forgot the key, it would be worth 1 out of 10 points. So you get 9 out of 10, no big deal. You can still get a ton of points for if you make a little mistake like that. Even if you make a little mistake like that on each of the Part 2 questions, you would still end up only losing 4 points out of 40 points. So you get 36 out of 40. You're humming along at 90%. You're doing great. Then they switched it to the present form with a few evolutions along the way. And now this question's worth 2 points. So if you lose 1 point, because we can only give full credit if it's perfect. So if you lose 1 point, you've lost 50% of the credit, not 10% of the credit. And that makes it extremely hard on you guys. Plus, you don't get to skip any Part 1s. Plus, you don't get to skip any Part 2s, 3s, or 4s. So it's much more difficult on you guys now than it used to be. Now, what they also try to do to balance it out a little bit is they curve the test. So, you know, it has 6 of one, half a dozen of the other. All right, here is my
my stem and leaf plot done perfectly. One of the great advantages to stem and leaf is it's so quick and easy to tell what the mode is. What's the mode on the stem and leaf plot?
32.
No.
No, 28.
No. Mode.
Mode? Oh, 20.
20. Mode means what, everybody? Most frequent, most popular. Mode. Most, right? Got that? Median. What is the median one?
25.
Well, I don't know what it is in this graph. It might be 28, it might not. I really don't know. But what is the definition of median? It's the one in the middle. Now, the way you can realize that definition, does anybody here intend to get their license one day and drive? For some of you guys might think about it a lot, like, I can't wait to get that car. I could see Hammer over there in like a Z28 convertible Camaro, zipping along all over the place before she goes out and gets her Porsche, which would be right before the Ferrari.
Which
Now-
will be right before Jay-Z.
Now, here what happens is this. If you drive down the expressway, there's often a sign that says to stay off the median. On the Long Island Expressway, what's the median?
The trash.
Well, sometimes it's a
The grass.
concrete wall, sometimes it's grass. It's that strip that runs right down the middle. So it's easy to remember the median means what's in the middle if you just think of that sign. And the average is the mean. Just add them up and divide by how many there are. Okay, now as far as a stem and leaf plot, when you enter this data into your calculator and you do, and I hope you remember the steps, it's stat, list, clear the top, enter all the data. Then you go to stat edit, one variable stats, one bar. When you do that and you scroll to the bottom, it'll tell you the min, quartile 1, the median, quartile 3, and the maximum. So, what is the minimum?
5.
5. What's the first quartile?
20.
What's the median?
29.
Third quartile?
30.
Max?
44.
Okay, now we go to draw the box and whisker plot. When I draw it, 0, 10, 20, 30, 40, 50, and I mark 5, 20, 29, 38, 44. Oh, I missed that mark a little bit. And there's my box and whisker plot. Mostly nowadays referred to as a box plot. Back in the day it was box and whisker. I keep repeating both because I want you to be prepared for both. Now, it's great if they ask you to draw one of these on your test. To me, that's like gifts points if you just remember how to put it in the calculator. And we'll do enough of it frequently enough that you don't forget. But what they often do is, without putting this information on the page, they'll look at you and they'll say, what is the first quartile? And you're supposed to look at the graph and be able to figure out from the graph where the first quartile is. And that's when you remember these 5 important points. 1, 2, 3, 4, 5. Here's my first quartile. It's 20. What's my third quartile? Now, I know it's a little tough to tell on this graph. It'd be a little more exact, but it would be 38. One last thing they talk about, IQR, which stands for interquartile range. That would be the highest quartile, which is the third quartile. That's not necessarily the highest, but it's always the third quartile minus the first quartile. Interquartile range, they want to know what's the range of numbers in the box. And that's going to be, in this case, 38 minus 20, which is 18. That's my interquartile range. Okay? Do we have any questions about that?
When we plug the list into the calculator, do we plug it in order on the top, or like?
Well, you're not usually going to have to make a stem and leaf plot. So you'll typically put it in whatever order they give you. Okay? Was anybody absent yesterday? Okay, good. Yeah, I was just going to say, if anybody was absent, if you have a friend who's not here today who missed yesterday, make sure they come down for extra help. And this, I'm not going to repeat the whole procedure because just about everybody in the class knows how to get it. Okay. So, we are now going into a little bit of making dot plots for today. Yesterday was box and whisker plots. Today is dot plots and trying to learn from it. So, they decided to go asking people about pets, and they asked a total of 30 people. I think it's 30. 3, 6, 9, 12, 15. It's 30 people. They asked the 30 people, how many pets each do you have? And they summarize the data in this table. Your job is to take the data in the table and make it into a dot plot. And I noticed there were 4 zeros, so I make 4 dots above 0. I noticed there were 7 ones. Might even be 8. 8 ones. So I make 8 dots above the 1. You guys finish the rest of the table.
Why do they go by twos? It's ridiculous.
It's just one of those lovely little things about the Common Core. I honestly believe what they do is they say, how can I trip up
10
students?
ones?
There's 10 ones. Yeah, there's 10.
Oh, there's 10? I thought there were 8.
No, that confused me.
Yep, there are 10. Okay. I think the Common Core likes to anticipate ways for students to make silly little mistakes and count them disproportionately so that they can lower their test grades and justify, well, the fact that they will say that by taking off all of these tedious little points, they'll draw the conclusion that you haven't mastered the material. When to me, mastering the material is understanding the material. I'm not doing tedious little points that, do you really need to do? To me, whether you recognize that scale is by 2s or by 1s is really not a measure of your mathematical intellect. And for that matter, neither is plotting dots. Okay, 2 gets 1, 2, 3, 4 2s. 4. 3s, there are 2 3s. There's a 4. There's 2 5s, 2 6s, a 7, an 8, a 9, a 10, and a 12. Okay, first, does this look like a symmetric graph or a skewed graph? Skewed. Definitely extra numbers to the left. Next, it asks you to calculate the mean number of pets owned by the 30 students. To do that, you would have to add up all 30 and then divide by 30. I believe it comes out to 3.2. That's what the last class said. Right, just add up all the numbers in the table and divide by 30.
You said add up all 30, like 30 divided by.
No, all 30 of these numbers.
There's 30 numbers.
Right, and then,
Just the average.
right, that's it. The mean is nothing more, guys, the mean is nothing more than the average. So we add them all up. I think it's 96, divided by 30, 30.2, whatever it works out to. Comes out to 30.2. Here's the point I want to drive at, though. The point is the very next question. Do you think that 3.2, I'm sorry, do you think 3.2 is a good representative number for the typical number of pets that a student has?
No.
No, definitely not. All right, I would tend to think 1, maybe 1 point something, 2 at the most. This data is messed up. It is literally what we would call skewed to the right because of these handful of big numbers at the end of the graph. If you have a tail to the right, we say it's skewed to the
Thank you.
right. If we have a tail to the left, the tail being the low part, we say it's skewed to the
That's the right.
right. So this is skewed to the right. The reason we call it skewed, I know it doesn't make sense. I had to go through it too and begin to understand it when I first read it. Here's why. If you didn't have this, the mean would be 1, agree?
Yeah.
But because we have this, it pulls the mean to the right. And that's what skewing does. Skewing adjusts the mean. Okay? So we would say that this is skewed to the right. It's the opposite of where all the numbers are. Okay? When I read that too, I was like, what? You gotta be kidding me. So, but anyway, that's what they do. So the point is, 3.2 is not a good measure of the average number of pets. Here's another example. Let's say you live on a particular street, and you saw this a lot down south. We went to visit Tennessee, and we're thinking of moving there when I retire. You would drive down a particular block, and it kind of worked in the reverse order. You would see like 2 really beautiful homes, gorgeous homes. Then you would see a double wide trailer with the grass overgrown and cars parked in, like so that the grass was so tall it was covering the car kind of thing. And then you'd see another mansion, and then another double wide, even a single wide, dilapidated, falling apart. And if there were 5 such places on the block, and let's say 4 of them sold for 100,000, 100,000, 100,000, 100,000, and the 5th one sold for 1.6 million, then the mean or average house price on that block is $400,000. 2 million divided by 4 or 5. Do you really think the average house on that block sells for $400,000? No, a much more representative figure for the value of a house on that block would be 100 grand. So there's not just one measure of what we call central tendency. There are 3 dominant measures, and range. Range is highest minus lowest, but the big ones are mean, median, and mode. Now we talked about mode, it's the most popular. We talked about median, it's the one in the middle. We talked about mean being the average. Now we have the tendency to believe from school, when we write your average, we always do, or your grade for the report card, it's always the mathematical average that we do. We add up when we divide, like we come up with the 3.2 here. But that's not always the best way to present a synopsis of the data, and this is a good example. From 3.2 on, there's only these few people. And this 12, and this 10, and this 9, and this 8 skew or mess up the data. A much more representative data would be these dots on the left. So when we say the average number of pets, or a typical number of pets, would be 1 or 2. Certainly not 3.2, and certainly not any of the numbers up here. Okay? So you have to be aware of that. The limits of the mean. Now, if the data was symmetric and not skewed, then the mean is a really good measure. Okay? Yes?
So,
How do you know what the real mode is? I mean, mean is.
You can figure out the real mean. You calculate it to 3.2. If you look at the way they worded the question, they were very careful to say the typical number of pets. They didn't use average. They didn't use mean. They said typical. The typical number of pets that people have here is 1. Maybe if you wanted to use decimals, 1 point something. It's certainly not 3.2. Okay? Very few kids have 3 or more pets. All right, so now we'll get to the next dot plot situation. I say that carefully because I keep thinking I'm going to stumble over it. Data set 2. They take some kids in the hallway and they measure the length of a hallway. 2 marks were made on the floor, 1 at one end, 1 at the other, and here's what they come up with. Go ahead, make your dot plot.
I'm ready.
As if to really emphasize the point, you'll notice this time they don't go by 2s.
It's ring. Hello?
Hi.
Nice try, Lorraine.
she's funny.
Okay. So the first question I see here is, why do you think the different students got different results? I mean, theoretically, if everything was perfect, they would have all come up with, 8.5 seems to be in the middle, 8.6, or maybe 8.55. Why different results? Go ahead.
Maybe they didn't put it exactly on the end, or tape measures don't start at 0, which I think is just stupid. Like, they start on 0.
Valid points.
So they don't.
Valid
Why can't
points.
it just
Because,
start it there?
because since they're so
Uh,
old.
Oh, tape
It's
measures do
okay.
start on 0.
Listen, hold it. We don't need to go too far here. It's also possible they didn't pull it tight enough, right? Or maybe another one had slack in it. Maybe another one started and then it moved a little bit and they didn't recognize that. And the bottom line is, the further you are apart, the more difficult it is to be exact. If I asked you to measure the height of this cup and you put the ruler right next to it, you got a pretty good chance of being super accurate. If I asked you to measure from here to Moscow, not so much. All right?
Well, Moscow's
Moscow's a
on the other
city in Russia.
It's on the other side of the world.
Right, and that's my point. My point is, the further you are apart, the more likely you are to make an error.
But they're talking about like from that door to the window.
Yeah.
Yeah, well, it's going to be a greater chance of error than the cup, but much less than Moscow. So,
Like a lot.
yeah, a lot less, I agree, but it's also a lot more chance for error than the cup. So,
Alright.
So the point being that there are reasons for a little bit of error, and when you collect data, there will be little disagreements, and it doesn't necessarily make things a big deal. Then it says, what's the mean length? We know how to do it. Add them up and divide by how many are. We know the median. The median, this is actually easy to figure out. The median is 8.55. We know that because this is the middle, this one and the first one on the other side. It's an even number of terms. When you do a median, you get two terms in the middle. What do? Take the average, right? Like if I did this, 1, 2, 3, 4, 5, 6, and I want the median, that's the middle. In this case, it would be 3.5. All right?
That's not what we did last time.
Median. Now, the next question is this data, well, let's go to a different question. Do you think the mean is a pretty good representative choice of this data?
Yes.
I do too. The reason is because if you notice, this data is pretty symmetric. It's pretty much the same on both sides of the maximum. That indicates that the data will be, mean is a good amount. It's balanced on both sides. When it's skewed like this, mean is bad. When it's skewed like this, mean is bad. But when it's balanced or symmetric, then the mean is a good measurement of what the average is. In this particular case, the median will be very close to the mean. I don't know if it's exactly the mean, but it'll be pretty close. Okay? All right. Let's go to the next one.
It's still there.
Age of cars. 25 car owners were asked the age of their cars in years. The results are recorded below. Go ahead, dot plot it.
0.
You okay?
Oh my gosh.
If you could hang on about 45 seconds to a minute, we're done. All right? And we can go in and I don't have to worry about you missing something. Okay. So dot plot is done. Would you call this data symmetric or skewed?
Skewed.
Skewed. And it's actually going to be, we might think of it as skewed to the right,
Skewed to
but
the
it's actually
left.
skewed to the left. Because those few really low numbers pull the mean down toward those low numbers there. Okay? Any question about that, guys? All right, you got some homework to start. Get rocking on that.
Did you start or did you finish? I don't know.
What'd you do? Fuck that up.
Anthony, I have a hard time seeing you angry. You're way too nice a kid.
I've never seen him angry, I've just seen him upset.
He's a good athlete. If I would have still coached wrestling here, you never would have made not on the team. You would have been on the team. I wouldn't have let you not be on the team.
Do you
You'd
think,
have been good, really good.
do you think wrestlers with one leg have an advantage, or
What's that?
wrestlers with one leg,
Or no legs?
or no legs?
Oh, yeah.
In some ways. Because it's all based on weight. And your upper body strength is gonna be so much stronger.
And they have nothing to grab onto.
You mean the guy going against them? Well, you do have things to grab onto. You just don't have the usual things to grab onto. There's a type of wrestling called Greco-Roman wrestling where you're not allowed to touch the legs.
Are you allowed to like?
You do headlocks, you throw.
Walk?
Yeah, no, you're allowed, you're standing up, but you just do upper body holds until you can throw them through the air.
Wait, can you do that in wrestling? Can you just get them in a headlock and throw them?
It's not that simple, because if you put me in a headlock, there's lots of things I can do to stop you from throwing.
You just kick backwards and like,
No, I don't kick backwards.
no, not like backwards, but
Like one of the best things to do is to put your hip in front. If he reaches up, the guy with the hip in front is gonna win every time. Watch, stand up and take your glasses off.
Oh God. You should put your glasses. Take your glasses off.
Now, this is called the classic headlock right here. If you start swinging him around,
You can just throw him forward.
and you pop your hip in front, the hip, you feel how the hip was lifting you off the ground?
I see how my neck is straining.
All right? The hip would, the hip would pop, the hip gets in there, and the hip pops him up off the ground. Now, if Nolan was to do that to me, go ahead, try to do it to me. Grab the left arm,
This arm?
This is why the weight class is a thing.
So disgusting.
okay? He's thinking he's got a headlock here, but if I walk my hip around and I come here, I can actually throw him. So there's lots of different things that you can do, and also if a guy tries to throw you in a headlock, you can lock his arm in. When he throws you to the ground, you can roll him through to his stomach.
You can always like grab their neck with your legs and go.
Actually, usually you're not allowed to scissor the head with the legs, but there are times and places where if you don't scissor your legs and you just use one leg to pick away, you can do it.
If you were coaching wrestling, I probably would have done that.
Yeah, same.
Oh, there's a lot of talent in this game for being a good wrestler.
Makes it look like. Oh God, does really?
Oh, every single stall is disgusting. I didn't go to myself. I walked in and I went out.
Surprisingly, the boys' JV locker room was pretty good.
Actually, why are you going the end of my job?
I know a lot of kids that go to
This is a very good school, a very good school.
Guys, why don't you get mad?